Today we'll be looking at the Newton's laws of motion. We have these three laws. Newton's first law, Newton's second law, and the third law. The first law states that a body will continue in its state of rest or uniform motion unless it is acted upon by external forces. The second law states that the rate of change of momentum is directly proportional to the applied force. Most of the times we see this formula, F is equal to ma. I will easily say that force is equal to mass times acceleration. But many students of physics don't know why this formula exists. And it is from the second law of motion, Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the applied force. And what is momentum? Product of mass and its velocity. So we can state this law mathematically as F directly proportional to m v minus u all over t. This is the change in momentum, or we can write this as F directly proportional to mv minus mu all over t, where this is what we call the change in momentum. So mv minus mu is what we call the change in momentum, the difference between the final momentum and the initial momentum. So we don't work with proportionality constant. So we introduce a constant, F is equal to k m v minus u all over t. And we assume that k is equal to 1 or unity. So this can be written as m v minus u all over t. And we know that v minus u over t is acceleration. So we can say that F is equal to ma. So we want to use this formula to solve a problem. And this is a problem. A horizontal force of 0.6 Newton acts on a body of mass 0.2 kg. There is a resistance of 0.4 Newton opposing the first force. What acceleration would be produced? So this is the problem, and this is how we'll solve it. We can sketch it. We can sketch this as the mass of 0.2 kg, and the first force is 0.6 Newton, and the opposing force is 0.4. Normally, when we have two forces acting in the opposite direction, to get the resultant or the total force, we normally subtract. So the resultant force now will be equal to 0.6 minus 0.4. This I Newton. So we can talk about F equal to 0.2 Newton. We now apply this formula. What we are looking for is acceleration. So we can say that F is equal to ma. Already we have known force as as 0.2, and then the mass as 0.2 kg is given here. This is Newton. So acceleration becomes force all over mass, which is equal to 0.2 divided by 0.2, which will give us 1 meter per second square.